Today we're going to begin our review over Chapter 6 in Geometry, which specifically deals with quadrilaterals. So we're going to go through some test problems to help kind of get you in the right frame of mind as far as these problems. So let's take a look at the first one. In this first problem, it says, judging by appearance, classify the figure in as many ways as you can. So first of all, if I clearly look at this, there are four sides. So you can clearly see that I know it is a quadrilateral. That being said, that means that I have to check down here. If it doesn't say quadrilateral, it can't even be an answer. So B would clearly not be an answer, doesn't include that. Also in this problem, I can tell that the four corners are marked as 90-degree angles. That means that I know that rectangle or square could be part of this conversation. Definitely a square, because I can see all the sides are equal. So I'm going through and I'm kind of looking for what's true. So quadrilateral has to be in there. So far those are true in that one. I just said by looking at the angles that they're a right angle and the four sides are equal, that I'm talking about the fact that it's a square. So I'm going to go through and just highlight that part. So square, square, square. Also, because of this, not only is it a square, but a rectangle says that opposite sides are equal. Even though all four of them are equal, opposite sides are also equal. So I could see how they could name this a rectangle. So if I choose one more color here, let's see, rectangle, rectangle, no rectangle on C. So that means C is now off of it. So the big case in A and D is to figure out really if these two can be also added to this figure. So in this one, a parallelogram would have opposite sides parallel and opposite sides equal in length. It looks like on this picture that that's true. A rhombus has four sides that are equal in shape or equal in length, which it looks like it has. So it looks like these two are also true. So that means that A is going to be our answer. Now that's one I think people have a hard time with, kind of narrowing it down. So keep that in mind. Let's try the next one. On number 2, it says find the values of the variable and the lengths of the kites of this, the length of the sides of this kite. So they want us to find not only the variables, but the lengths. So first of all, if I were to set these up, I know that those two are equal, and I know that these two are equal. Now, because the yellow ones have two variables, they have an x and a y, it's probably easier to start with the pink ones because there's only one variable. So I have 2x plus 2 is going to have to equal x plus 11. So I'm going to add a 1 here, and then I'm going to go through my solving. So I'm going to subtract 1x from both sides. And then subtract 2. So basically this gives me x equals 9. Now in this one, if that were true, that means this side would be 20. This side also would be 20. And also, I would have to go solve these sides. Now I know this one at least. I know that this has to be, x has to be 9, so 9 plus 2 would be 11, which means that on this side it's also going to have to be 11. But I know that that side is y minus 2. Which would give me y to be 13. So in this kind of a problem, I have, let me circle this, x equals 9, y equals 13, and the two sides are 11 long and 20 long. So that means out of the answers that are up here, that C would have to be our answer. Now, this is the one where people are going to go crazy, because this is the problem, I think, that is probably the most challenging in the test. So this one says, what's the most precise name that you can give for this? So I'm going to start, first of all, by taking this and actually graphing it so I know what I'm looking at. So -5 and 2 would be right here. B is -3 and then 6. Then 6 would be C. And then 4, 2 would be D. So I'm actually going to grab my line here, and I'm going to make some straight lines between these points so I know what the heck I'm looking for. Now, first of all, I can look at that and think probably a parallelogram is my guess, just by the way that it looks. But we have to go through and actually figure out a bunch of stuff about it. We have to know the slope and the distances of the sides if we're going to know if they're parallel or if they're perpendicular or if they're the same length. So I've actually kind of set this up by putting points here. So I'm going to show you a little bit about my technique. So I've just done this, so now I can go back in and I can actually write my points. So I know A is -5, 2. So -5, 2. I know that B is -3, 6. So notice every place that I have A and B, I'm writing it. C is going to be 6, 6. And D is 4, 2. Now really what I want to do is I'm going to focus everything on this line is going to be about AB. Everything in this line is going to be about CD. Everything in this row is going to be CD. And everything in this row is going to be DA. And we did say finding the slope is probably the easiest way to go. So we're going to start out finding the slopes for all of these. And then we'll use those to find the distance. So slope here, if I were to start, it's the y value, so 6 minus 2, and -3 minus 5. So that means that on top here it's going to be 4. The bottom it's going to be a +2. So I'm going to keep going all the way down, but I know eventually this part's going to equal 2. Now the way that we do distance is you have to use this part of the fraction. Really, this is the differences between the y's and this is the differences between the x's. So I just need to go over here, be able to square them and add them together underneath that square root. Now because 4 and 2 are positive, I didn't do any parentheses. Might have to do parentheses if that were true. But these together would give me the square root of 20. Now I go through and find that if I want, but actually if I look at this picture that's up here, AB and CD are really the only ones we're going to have to find distance for. Because I know if I were to count here, this is right on the line. So 1, 2, 3, 4, 6, 7, 8, 9. This is 9 long from B to C. So I actually know the length is 9 there, even without going through the distance formula. Down here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 down here as well. So that means that I also know this one is 9. Okay, let's go back to our slope here. So 6 minus 6. And actually, I don't even have to do the bottom, because if it's 6 minus 6, I know my slope is going to be 0. Down here, the same thing's going to happen, because I have 2 minus 2 here. And I can keep going on the bottom, but I know that because the top is 0, that's going to equal 0. Okay, let's go to CD. So 6 minus 2. and then 6 minus 4. So this is 4 over 2, which is 2. Okay, now to set the square root up, we use this fraction part and square them and add them together. Well, gee, doesn't that look familiar? Give us the square root of 2. So, if I look in this, I have one pair of opposite sides that's equal, another pair of opposite sides that are equal, I have a pair of opposite sides that are parallel, and a second pair of opposite sides that are parallel. So, in this kind of a problem, I have two pairs of opposite, congruent, and parallel sides, which means that our answer down here is going to have to be C. Okay, let's see if we can maybe squeeze one more in here, for our time is up. So on this problem, they tell us it's a parallelogram, and they tell us that CDA, which is this angle right here, is 66 degrees. And they would like us to find BCD, which is this one right here. Now, because of the way these two are set up, they have to be supplements of each other, which means that if I take 180 and I subtract 66 from it, that's going to give me this leftover angle. So if I subtract that, that's 114, which means that C is my angle. They only want you to find the angle. So once you figure out this is 114, that's all you need to do. Now in this one, it tells us it's a parallelogram, and it says that DAB is 115, and they'd like us to find BCD, which would be this one right here. Now those are opposite angles. In a parallelogram, we know that opposite angles have to be congruent. So if this one's 115, then that means that this angle here that they're trying to find again is also 115. Okay, let's try another. Okay, this one, it says that NM is x plus 15, and OL is 3x plus 5. We know it's a parallelogram. They want us to find x, NM, and OL. So I'm going to make my little answer box here like I normally do. So first of all, I know that if these are opposite sides and it's a parallelogram, I have to know those opposite sides are equal. So my first job is going to be to set those equal and solve. So 3x plus 5 is going to have to equal x plus 15. Add my 1 there. Subtract 1x from both sides. So it's 2x plus 5. These cancel and I get 15. I'm going to subtract 5. So I get 2x equals 10. So I get x equals 5. Now just based on the fact that x equals 5, you know that A and C can't even be an answer. So we're down to the fact that it's either D or B. So if I go back in there to find NM, NM is x plus 15. I know that this is 5. So that means it's got to be 20. So I know that NM equals 20. I also know that I have to find OL, but OL has to be equal to NM because they're opposite sides. So that means OL also has to be 20. That means as far as choices up here, that my answer is going to have to be B.